Cool. Right. Yeah. So thanks everyone for joining the 102 again this morning. Today we have got Tom and James. Tom, I don't know if you would want to share or not to get your slides or anything. Um,
Yes,
we've got Tom and James from IBM, and they are going to be talking about Ansible again and Tecton and all good things CI/CD. So we had like a bit of an introduction to Ansible yesterday from Andrew and Drew. So this should be a perfect session to follow up on what we learned there. As always, please can you fill in your session feedback? Hopefully everyone should be used to doing that now, being that we're on to some of the last sessions. And yeah, take it away basically. Thank you, Tom. Thank you, James.
sure. Hello, everyone. I'm Tom Slattery from the CICS Customer and Production team, and we're joined today by James, who's the undergraduate placement student in the CIP team as well. And I had a last minute tweak to the title of this presentation just because I wanted to really try and pack in all of the technology that we're going to be going through in this presentation. So really I wanted in there to sort of have references to CICD, a sample application for CICS, and then a CICD framework and a deployment tool with Ansible. So just wanted to sort of give an overview of all the technology that we'll be talking about today. My plan for the talk is I'm going to start by giving a bit of background about customer and production testing in CICS and how that's led us towards creating a CI/CD pipeline for our development. And then we're going to sort of take off from there into quite a few demos. So this is going to be quite a demo-heavy talk, but there's a bit of explanation at the start. So I feel often the best way to introduce the CIP team is just literally to introduce a few of the CIP team members. And one of the most important things for customer and production testing is communication with customers of IBM. So I put this slide in with all of our contact information. So if you want to go and download this slide and talk to any of us, we're all available to chat here. So the customer and production team for CICS tries to bring together a group of people with a wide range of skills in sort of across the breadth of skills needed to develop a CICS application. So we cover application development on Z, but also have systems programming and security experience, as well as DevOps engineering, Java skills for test development, that kind of thing. And we had a really a specific goal in bringing together this group of people from the wider CICS department. And I feel this is represented by our mission statement here. So our goal in customer and production is to act as the first customer of CICS. So a customer-centric approach to testing CICS. To do this, we develop an actual CICS application, which is modeled on feedback that we've got from customers of IBM on the kind of systems that they're creating. So we tried to design an application that was sort of an amalgamation of all of that feedback from customers. So a sort of production environment that is representative of the wide variety of applications that can be created using CICS. And a really crucial aspect of our mission statement here is that last clause there, the ensuring that both continue to function. We were finding that there's an aspect of testing for CICS that just wasn't quite covered by the sort of systems testing and integration testing. We wanted a form of testing that sits sort of a level higher than integration testing. So what we created was our application and our production environment on which we run our application, and we try and sort of run it like a customer would. So with constant availability and with automated workloads that are simulating daily usage. Our application is based on banks, so we've created the Bank of Hursley Park application that we run in our production system, running constant sort of workloads of transactions. And the really important aspect of having a production system is testing that we can roll out upgrades to it. So rolling out new versions of CICS without affecting the currently running workloads. Because if we can't do it, it's going to lead to problems for customers of IBM. So I've mentioned the Bank of Hursley Park application, and I want to introduce another application that we created as a result of all of the sort of feedback, all of the customer interaction that we had in developing the Bank of Hursley Park application. So we created this application called CBSA, so CICS Bank Sample Application. What we wanted was, while designing the Bank of Hursley Park application to be highly configurable, customizable, and a representation of a wide range of customer systems, we wanted to create something that was a means of communication with customers of IBM, a demo that we could create for a CICS application. So CBSA is sort of a distillation of everything that we learnt in developing the Bank of Hursley Park application. And we made this an open source offering so that it would be available for customers of IBM to look at. And it would also be something that we could use with our tech sellers to demonstrate different products and the way that they interact with CICS. And we really wanted to ensure that this wasn't a short-lived single-use demonstration for a specific purpose. We wanted a general demonstration that would be maintained as we maintain the Bank of Hursley Park, so something that would remain relevant to customer scenarios. So the Bank of Hursley Park, the CBSA is a sort of hybrid 3270 terminal application. It has Liberty, Spring Boot, and z/OS Connect options for configuration. And it also has configurability of data store, so it can use DB2 or vSAM or a mixture of both. And our goal here was to try and sort of filter down from the wide range of configuration options for the Bank of Hursley Park application to something that is representative of a range of customer scenarios, but is also not that difficult to deploy. And our goal with CBSA is for this to be a growing project and a way for us to interact with customers, a way for us to gain feedback. So a sort of two-way street of demonstrating what is possible with CICS technology. Now, in developing the application, we wanted to also embody the kinds of development processes that we both see in customers and also that we want to recommend to customers. So in doing this, we wanted to adopt a CI/CD pipeline for the development of CBSA. And to help me explain this, I've created these two personas, which are representative of personas that we have in the CIP team, but also might be representative of the kinds of people working at customers of IBM developing CICS applications. So I've got Alan, an application developer who's got experience with COBOL development, is working on the source code for CBSA, currently manually deploys CBSA test environments to a Z mainframe for testing, and also is experienced with the current state-of-the-art tools for development. So at the time when we first started CBSA, that was using Rational Team Concerts as source code management and development tools, including Eclipse as the IDE. So just to reiterate, what I'm planning to do here is to demonstrate the state before modernization and then how modernization benefits these two personas. So we also have Greg, a DevOps engineer who is an infrastructure architect, has experience more around the cloud computing side, but also some mainframe interaction as well. Has experience with different automation frameworks, including Jenkins, Tecton, perhaps names like Travis might be familiar as well. And Greg has got a goal of modernizing the CIP build process to reflect the current state of art for CI/CD technology. And as a part of this, he also wants to encourage better quality control practices for the code base. So introducing checks on the code that is being committed by Alan. So a quick overview of the as-is of the CIP build process. This is the build process that we used in developing the Bank of Hursley Park application. And I covered this in quite a lot of detail in my other session on CIP modernization and transformation. So I'm not going to go into too much detail here, but this was a process that was manually triggered by developers. So developers would submit change sets of code to RTC. By the way, for continuity of terminology, a change set in RTC is roughly equivalent to like a git commit and then a push in GitHub, and that will become especially relevant as we transition to GitHub. But yes, a developer would be working on Bank of Hersley Park code. They would submit code to the source code repo, and then they would need to trigger a manual build process. This would be an ANSI build that would produce artifacts, and then an urban code deploy, a set of urban code deploy steps that would bring up a CICS running the Bank of Hersley Park application and install the application across the CICS. Next, the developer would need to test that the application satisfies their standards, and that would involve running manual tests, so actually operating the bank, or running automated JAT tests for which is using a sort of IBM internal homegrown test tool. And then also for the production environment, that could involve longer running tests using automated workloads using TPNS. Now, if satisfied with the result of the tests, the developer can then promote code to the best so far repository, and they would then need to manually clean up their environment. So they are responsible for the life cycle of the test environment. So just a couple of key themes there is, firstly, the pipeline as is, it was manually triggered. So the developer would complete the action of submitting code to source code management and then would think, I need a test environment. So they would begin to the manual process of starting this pipeline. There would be a lot of steps that would involve waiting. So the ANSI build would complete, and then the developer would need to, once they've received feedback that the pipeline has completed that step, they would then need to go and trigger the urban code deploy steps. So waiting, then triggering the next steps, then waiting. There's also a really crucial aspect of the testing. So there were manually running tests, and then also to satisfaction of the developer is quite hazy as a term. So really, the quality gate on the code was just checking if it met the developer's standards. And as you know, developers are people and are fallible, so we all make mistakes. There was often times when mistakes would get through this process or things would be missed by the manual testing. And finally, a sort of meta point for the whole pipeline is the life cycle of the test environments was something that was managed by the developer. So the developer would need to decide that they needed a CICS running CBSA, and then they would also need to decide when they wanted to get rid of that CICS, so they would need to run the cleanup step. And that often caused problems in the pipeline because we would forget to run cleanup, and then we'd find the next run of the pipeline would encounter problems deploying. So these were the key points I wanted to address. So manual testing, ensuring quality control of the code, and life cycling of the test environments. So just a few, sort of distilling those into concrete objectives for those personas. Firstly, automation would be a really good thing to introduce to this pipeline. So accelerating the speed of development, removing those manual steps. Configuration as code is another developing theme in CI/CD technology. So in our urban code deploy application, while it forms just one block of that diagram, it was actually a really complex urban code server, which contained a lot of configuration for us. And that wasn't change managed. So we didn't have version control over all the aspects of the configuration that we had got on that server. So adopting an approach that allows us to have all of our configurations stored as just text files, which can go into a GitHub repository, would already bring a massive benefit over that way of handling deployment. And finally, a really key aspect to introduce would be shift left testing. So not just introducing automated tests, but actually ensuring that the pipeline is designed so that it fails early. Now, that kind of can sound quite negative, failing early, but really the actual goal there is the pipeline completes minimal work promoting code that wouldn't meet the requirements, that wouldn't be satisfactory. So ideally, the developers find out that their code has got problems in it as early as possible. And this will lead to a higher quality code base and a more reliable application. So a few specific goals just related to those personas that you may be able to relate to in your own organizations. So firstly, bringing about continuous integration and delivery. As a result of this, the code developed by the application developer, Alan, that code would be frequently tested, so he would have a better assurance of quality before merging into the source code management tool. Code being frequently integrated would facilitate faster collaboration between the team and foster a sort of a feeling of agile development, and also would result in a more easy process for rolling back changes as well if there are problems that go untested. And finally, Alan now would no longer need to manage their own development environment. That should be a resource that is life cycled by the pipeline. We also get test reporting from a modernization of this pipeline as well. So automated tests could produce logging and could also produce reports on pass rate and failure rate. And this has got benefits for the application developer, but also for the DevOps engineering and for management. This can provide a really nice overview of the current state of the features of the application under test. And finally, as an objective for CIP, a really important thing for us is demonstration in the customer and production team. So we really want to show how CI/CD practices can be adopted by a team working on a CICS application. So not only a demo of what's possible in the technology space, but also a demonstration of a roadmap for adoption. So I think that brings us to, introducing the first element of the modernized pipeline for the CIP team. So what I wanted to tackle first was the Urban Code Deploy application deployment side of this pipeline. So I needed a tool that would allow me to handle deployment of CICS applications, and I started to look into Ansible. Now, I think there have been some Ansible talks already, so just a quick refresher. Ansible is an open source automation framework, so it's available to use now. It uses SSH to communicate with a host system, which is referred to as a managed node in Ansible. So you have a control node, which can send out commands, and a managed node that receives commands via SSH. And this allows you to actually create quite complex automation targeting multiple different platforms. And it's highly well suited for application deployment and orchestration, and with a focus particularly on security as it's using SSH. So the benefits that this would bring us would be infrastructure as code. So on a level higher than configuration as code, we actually have Ansible playbooks, which are entirely defined by YAML. So all of the automation and the configuration of the automation is defined using YAML files, all of which can be stored in source code management. Ansible playbooks are very readable. So YAML is really a data storage format. So a very readable collection of information. And also Ansible logging is absolutely fantastic. The log produced by Ansible to the terminal is very readable and separated into really nice sections. So very easy to debug. And the final really important feature of Ansible is its extensibility. So the Ansible Galaxy collections is a repository of a large number of open source contributions to the Ansible feature set. So there's a growing suite of plugins for Ansible, and the Ansible Galaxy collection stuff is all vetted, so you can all use that with a degree of certainty of security. Now, I want to introduce the first of the new possibilities which are offered in the Ansible space by the IBM Ansible team. And I'm going to be showing how we've used these collections in our modernized build pipeline. So just a flavor of the things that are possible with the IBM z/OS core collection. So you can do the common tasks that you would want during your application deployment. So such as submitting JCL jobs on z/OS, but this happens from a local machine. You can manage files, so copy, moving, and also handling file encoding, which is a key feature on z/OS mainframes. You can also query results of jobs. So this is a really important feature for making pipelines dynamic and responsive to tasks that are currently happening on the managed node. You can also issue TSO commands and allocate datasets. Layering on top of this functionality, we also have the IBM z/OS CICS operator. Now, this collection allows you to provision entire CICS regions from an Ansible playbook. And on top of that, you can also clean up the environment and remove the CICS region again. So from these pieces, I will be building a deployment pipeline for CBSA. That all layers on top of the features which you get just for free by having Ansible already. So Ansible playbooks allow you to use Ginger templating. You can run bash commands against a host. So controlling your managed nodes. You gain configuration as code from using configuration stored in the Ansible inventory or in config files. And you can, of course, bring your own text editor. So in this case, I use VS Code for these demos. I just want to loop back. I did say you get this for free when I mentioned the Ansible playbooks there. I don't want that to sound like any of this stuff is paid functionality. This is all open source tooling that you can use now. So yeah, just clarifying on that. So that brings us to demo 1. So what I'm going to show here is using a sort of a collection. Collection's the wrong word because I'm already talking about collections. A grouping together of some of the features from these Ansible collections to achieve a task that was part of the pipeline for deploying CBSA. So if I escape from my presentation, I'm going to bring you over to a VS Code window here. Can everyone see that? How is that for size? Is that visible? I take that as a yes, because I've got it quite big. So what I'm going to show here is just an example of an Ansible playbook. So what we have here is a YAML file, which is just called submit JCL demo. And what I'm going to be doing is using an Ansible role, which comes from the ZOS CICS operator collection. The way Ansible playbooks work is they are pretty much an array of tasks. An Ansible task is a single piece of work that is going to happen either locally on the system that's running the Ansible playbook or remotely on a managed node defined to Ansible by the inventory. So what I've got here is a Ansible task, which is using this role called z/OS job submit template custom. This is a role that I've created, actually, this one. And what it's going to do is it's going to take a piece of J2 Ginger text, which I've got in my templates folder, and it's going to submit it. I'll just open the role to show that quickly. So in my z/OS template custom, you can see I have got here a step, which is running z/OS core job submit template. And it is taking in the piece of JCL template from templated job.path. So what an Ansible task really looks like is it's pretty much a call of a module and then inputs to the module, where a module is a piece of Python code which you don't need to interact directly with Python as an Ansible user. You just have to pass it the correct things from the module. Now, what I've got here in my templates folder is startkics.j2. And you might recognize this as a piece of JCL, but with some strange formatting features, some unusual syntax. So what I have here is some JCL that will start a CICS region on a development plex that I've got access to. However, it has got Ginger templating format. So everywhere that you see these two curly brackets, these are actually variables that Ansible is going to put in for me into this file. What this allows me to do is I can define outside of this piece of JCL on my local machine a set of variables for my instance of the Bank of Hursley Park application. So you can see here I'm setting all of these variables, but I also have variables for the CICS region, and I have variables that are specific to the host that this CICS region is being deployed onto in my inventory here. So what this allows me to do is I can actually use that one piece of JCL to provision CICS regions across multiple different hosts if I want to, as long as I have variables which are relevant to each of those. So a little bit of reduction of repetition of code. So what I'm going to do is I will just grab the Ansible playbook command to submit this, which I have got just written out in a file somewhere. Here we go. Submit. So what you can see from this command here is I'm calling Ansible playbook and I'm saying, give me this inventory, use these vars files full of variables, and give it a host and an Ansible user. So I'm just going to run that, and you can see that it's running submit JCL. Now, I have to warn you, this is going to produce a big chunk of red text that looks like an error. This is actually not an error. That is me not waiting for the job to complete. But what I can now do is, as a result of submitting this CICS region, I should be able to go to Plex 2 and log on to the CICS region. You can see that is now running. I can type Omen, and we get the Bank of Hursley Park the CBSA main menu, the CICS Bank sample application main menu. So this seems like a good opportunity to just do a very brief tour of what CBSA looks like. So we modeled this on a banking application. So it's got the kind of features that you might expect a bank teller to be faced with. So displaying customer information, we've got a large number of randomly generated customer data. And we've got accounts which are generated into a DB2 database for those customers. So that's a demo of the sample application. Now, we actually have a web UI as well that I'm not going to show here, but that's just a slightly updated user interface that might be more familiar to the bank teller of 2024. Now, I'm going to jump back to my slides and introduce our next demo. So just to recap on what was required to do that. So firstly, I needed to, okay, this is outdated. I didn't need a CICS region provisioned on Z because I actually, I now have an operator collection that can provision that for me. So I need to update this, but what I did need there was I just needed to have the data sets in place to submit my JCL to start my CICS region. I also needed to create an Ansible inventory that targets the Z mainframe from my local machine. So that Ansible inventory points to the mainframe, and it also specifies what SSH key to use on my local machine to authenticate with the mainframe. And on the mainframe side, there's only two tools that I actually need installed to allow me to use Ansible. ZOAU, so Open Automation Utilities for Z, and Python for Z. That's all the tooling that's actually needed to run Ansible. Now, in the process that I'm showing for my demo, I have just deployed CBSA to a CICS region running on Z. So you can imagine the developer might have just created this CICS region to test that their application meets their requirements. So we currently have running CBSA, but is it actually any good? Does it meet their requirements? So what the developer now needs is a means of performing an integration test against that test environment. And we didn't just want this to be a manual process. We wanted to adopt a tool that is currently recommended by IBM for integration testing on the mainframe, and that is Galassa. So Galassa is an open source offering in the space. It's an open source integration testing tool for Z mainframes. There have been a few Galassa talks previously at GSE, and you may have caught those. What we're going to be doing for this next demo is just showing how to run a regression test against a CICS application using Galassa. Now, to do that, I've brought James Ford with me. James has been really good and has written all of the Galassa tests that we currently use to test CBSA. So he's the expert on Galassa testing. So what I'm going to do is I'll jump out of the slides and I'll go over to VS Code. And while I'm doing that, James, do you want to just talk a little bit, introduce yourself and introduce Galassa?
Yeah, of course. Expert might be a bit of a bit too high for me, but joining the CIP team as like a placement intern, my first task on the team was to like architect a solution for testing CBSA using Galassa. So as Tom mentioned, Galassa was the team's open source testing framework, well, that we were recommended to use. From my experience, or from what I know, it was developed from JAT, and then open source as it provided a way of Z integration testing, and also open sourcing provided a common testing platform. So coming in and joining the team, most of my experience was with Java, and I had a little bit of experience with JUnit from some previous group projects. So jumping into writing these tests on Galassa was completely new for me, and I was doing things that I'd never done before, like interacting with green screens, and well, not necessarily interacting with green screens, but learning to interact with green screens through automating green screen interaction using Galassa, which is a bit of a wordplay, a bit of a handful there. But I came in having never even used a mainframe. Like, I didn't even know what it really was until I started writing these tests for it. But thanks to like the open sourcing of Galassa, there was an abundance of existing managers that I could kind of build up knowledge from, and a bit of documentation, but it was mainly the existing managers where I'd look at them and then I'd be like, where can I transfer what already exists into what I want to develop for testing CBSA? So there are a number of interfaces that require testing for CBSA, but the main one was interacting with the ZOS 3070 terminal. So breaking my task down when I got into it, it was initially writing just tests. Joining that, I went in there like, I'm just gonna have to write tests. I don't even care what managers are. That's not even gonna be a problem. That was a bit of an understatement. Really came in there quite shallow, but I ended up having to write my own managers that I developed. So managers in Galassa can either be like quite general purpose, such as like a HTTP client manager, or more focused to the application you're testing, such as the ones that I wrote. So I wrote a CBSA account manager, a customer manager, and then the main one was the CBSA terminal manager. This one extended the existing ZOS 3070 terminal manager. And through this extension, I created a number of methods that would almost cut down the routine tasks that were being performed in the testing into like these methods. So for example, if in the test you were having to log on, go to the main menu, enter one to navigate through these interfaces, I'd cut them down into these methods where it'd be like, go to customer interface, trying to make it more highly explainable in the manager. So the CBSA terminal manager was the main manager that I wrote, as both the customer manager and account manager also use these to navigate. As I'm showing, you're looking at the CBSA terminal manager. So we've got, for example, log on to application. So I was cutting away all this like unnecessary stuff that would be in the tests, a way of basically reducing the amount of boilerplate code and providing proven tool interaction. That's kind of what these managers do. So these login to application, obviously this step's going to be done every time you're in the test. Or in the manager for accounts, you'd be creating an account, deleting an account. All these steps could be chucked into these managers instead of put into your tests. But coming in, I was able to create value for the team without actually having any experience with mainframes, as Glass is not to be like overly, what's the word? Overly excited about it. Like it's just Java, really. Like you don't really need anything more than that. But if we jump to can we jump to the tests and then I'll start having a look through those.
So I think I'll give the test a run and just show what happens when you run test customer.
Yeah.
Just to echo some of what James is saying, so I'm also a relatively new joiner to Z, so I've been here about 5 or 6 years, and I also, in my experience, I came from university with Java skills, but not really with a background in mainframe technology. So having something like this to start with, I found was a really good entry point into understanding ZOS, understanding interactions with the 3270 terminal. So, I wasn't just building skills in, and James wasn't just building skills in operating 3270 terminals, but actually in learning to do that, providing some value for the team, a reusable asset in creating these tests. You can see we've got a test pass here, James.
That's what we like to see.
Yeah.
Did I walk through a bit of the test class and kind of get
that? Yeah.
If we go to, so if we go to test customer, so if we go right to the top. So at the top, we have these annotations where you can see at CBSA customer. This is basically telling the Glasser framework to go ahead and provision these resources for the tests. We then provide a reference to them in the, as you can see, customer. The tag where you see existing equals false. So when you're provisioning these managers here, you can provide tags as long as you set them up in the manager. But these could be for port numbers or any other configurable options. But here we have existing equals false. So we're basically saying we don't want to go and grab an existing customer. We want to go and make a new customer for our test to be run against. And this is also, well, it's not also, this is a way of how we try to be idempotent in our tests and life cycle our resources so that it's all going to be cleared up at the end and we're not like leaving anything left behind. So so we've declared both of them there. And then similar to JUnit, we've got before and after classes, and that's something I recognize from my university experience. And then if we were looking at test is where we have one of our first tests. So an at random customer. So terminal, where that's our CBSA terminal, dot wait for keyboard, dot type, dot enter, dot wait for keyboard. It's all very simple, almost like a natural language sentence. Like anyone could really kind of understand what's going on there. It's all very simple. But anyway, this would be navigating through the green screen using the CBSA terminal that we set up to do these options. And then using an assert that statement here, we're able to, well, not assert that, but we're able to retrieve the screen and then using assert that, we can check that what we expect to be displayed is actually up. So for example, we want customer lookup successful. And if it is on the screen, then we know that finding a random customer has gone well and has been a success. And if it's not, then it's failed. All our tests kind of use assert that or similar methods to check that. Well, not all of them. In terms of the ZOS 3070 interface, most of them use assert that. But when we were testing the other interfaces that Tom mentioned, such as the React, it would be a different methods.
Yeah.
I think that's most of the tests.
I think that provides a really nice overview of the shape of a Glasser test and the way. Also, I feel James has really gone through the kind of model process for designing Glasser tests here, really in finding appropriate managers in what's offered in the open source by Glasser, and then realizing that there were ways to even better improve the tests by extending those managers to create an application manager. So in this case, James has created the CBSA manager class here, which really kind of acts as the interface from the test to CBSA and really cuts down on the sort of boilerplate code. As you can see, the test methods in here are quite short, and what they're doing is not simple. So that's really allowed to happen by the creation of the manager. So thank you very much for talking us through that, James. It's been really good. I've got a run log from the test here as well, where you can see the test has produced the 3270 terminal screens that it's operated. And we also should have artifacts, which are just nice little screenshots of everything that the terminal saw in the test process. So, what have I got to remember to do, James?
End of
I've
demo
got to
provision.
end of demo 2. I have to get rid of the CICS region, ready for demo 3. So there we go. Right, good. So at this point, we have demonstrated the 2 really key features that we want to have in a deployment pipeline or in a CI/CD pipeline for the development of CBSA. But we've shown them locally so far. So what I really want to do now is put names to all the technologies that I'm going to use to tie this together into an actual automated pipeline. So just to put some names to the bits of technology that we're using, I'm going to introduce Tecton here. Tecton is an IBM open source tool which allows for which really manages the entire CI/CD lifecycle of a pipeline. You may be familiar with tools like Jenkins or Travis. I'm actually a Jenkins convert to using Tecton, but really you can imagine Tecton as sitting in the kind of role that you would use Jenkins or Travis for. It's the high-level automation orchestrator. I'm going to go into more detail about Tecton in a bit and the particular way in which it uses containers because I've got a demo to talk through. But just as an overview, we're using Tecton as the CI/CD framework. We're using Ansible as our deployment platform for deploying CBSA to the mainframe, and this will be automated from the Tecton CI/CD framework. So Tecton is running Ansible. Now, for testing, we're going to use Galassa. What you've seen so far is Galassa running on a local machine, but what we're going to be doing is extending this into automation by using the Galassa ecosystem. You can imagine a Galassa ecosystem as an automation server for running Galassa tests on Kubernetes. And lastly, we've got a bit of a technology transition here from using RTC as our source code management to using GitHub. Now, the shift to GitHub Enterprise was something that we wanted to do in CIP as it represents an industry-wide shift that we've observed, but also to align us with the current practices which is happening in CICS. We've all transitioned to using GitHub Enterprise and CICS at the moment. So that brings us to the revised CBSA or the improved CBSA CI/CD pipeline. So I'm going to do a demo of this and I'll talk through that in more detail, but just at a high level, this is what the pipeline now looks like. So the redesign of this pipeline firstly addresses that sort of manual triggering of the pipeline by making this event-driven. Tecton really supports the event-driven model very well. So what we wanted to do was create a pipeline that really has automation triggered by actions that a developer already wants to complete. So as an example, a developer wants to move code from their local machine into the repo. And in creating that pull request, we want the pipeline to be triggered. So using event listeners, we're able to sort of centralize the pipeline around movements of code. The Tecton pipeline is started and provisioned to CICS region using the ZOS CICS operator and the ZOS core Ansible Galaxy collections. It compiles and installs the version of CBSA that is being pushed by the developer in their pull request. And this creates a test environment. Next, we can run Galassa tests against the test environment to check that it matches the standards required for the repo. And we want this to be a bit more of a hard requirement than than previously has been performed in our pipeline. We want this to be a quality gate. So we have regression tests written in Galassa, which are the tests that you saw were written by James. And the test results for those tests act as a quality gate for the code being submitted into the main repository, into the main branch of the repository. So we don't just want this to be something that's reported into sort of an obscure place in the pipeline. We actually want this to go right back to the interface with which the developer triggered the pipeline. So we want this information to go straight back to the GitHub PR. And finally, we want to manage the life cycle of these environments. So we want the environment to live for as long as it's required. And I've defined that currently to be the length of time that the pull request is open. So closure of a pull request will destroy the test environment. So that means that we no longer have these developer managed environments. That brings us to the full demo of the CVSA CI/CD pipeline. So what I'm going to do is I'm going to be hopping between a few desktops on my laptop. I'm hoping it's not too difficult to follow. But what I'm going to start by doing is going over to this VS Code window here. What I've got in this window is the CVSA source code that I've pulled to my local machine. So I've got a source folder in here, and this has got actual COBOL programs for CVSA. Again, I want to reiterate, this is open source code, so you can go and pull this repo yourself and have a look through, or try deploying it yourself. Now, what I'm going to do is I'm going to create a new branch in this repo. That has appeared right behind the WebEx bar. Nightmare. Let me move that down a little bit. I can't get rid of this bar, so okay, I'll just put it down here. So I'm going to create a branch called GSE virtual, and I'm going to submit a change here, and I'm going to change this README to say hello GSE virtual 2024. I'm going to save that, and I'm going to commit this to the repo. So change for GSE. Okay. So what I've done there is I've published a branch to the GitHub repo, and this is a common task that you would want to do in developing code, application code. You would commonly create branches, do your work in the branch, and the action for closing a branch would be to create a pull request to take the code that's in your branch and move it into the main repository. This is the point where we want gatekeeper tests. So what you can see in this window here is I have got the GitHub Enterprise repo open here for CVSA. This is my fork of that repo, by the way. So that's why it's looking slightly different to the open source one. So I'm going to compare and pull request here. So I'm just going to say change to the README to trigger automation. And I'm going to create a pull request. Now, what I really want to show here is I want to simultaneously show what is happening in the automation and the changes that would be reflected in what you would see from the UI with which you create the pull request. That pull request is taking a second to go through. There we go. Good. So what I'm going to do is I'm going to split the screen, and I'm going to bring up the Tecton dashboard. Now, I just want to frame this correctly because I don't want to imply that you would ever need to look at the Tecton dashboard to run these tests. This is not the automation hub that the entire team will be looking at. I'm just using this as a demonstration tool for now, just to allow us to follow through the progress of the pipeline. What the developer will really be using is this window here, this GitHub pull request, to receive feedback on what's currently happening for their pipeline run that they've triggered. So I've got a little bit of time now while this pipeline runs. So what I'm going to try and do is I'm going to try and cover some Tecton concepts, and then I'm going to drill into a little bit more of what we're seeing on the GitHub pull request. So to start with, Tecton has got a couple of differences between the way it runs compared to Jenkins. So I feel that the comparison to Jenkins is a really good way to highlight particularly the core of the Tecton model. So Tecton if you have used Jenkins and you've used cloud configuration and you've created a Jenkins agent, which is a custom image, you're sort of beginning down the path that led to the development of Tecton. So Tecton has got an individual container for each task that it's running. So what you're looking at is sort of like a Kubernetes pod. So each of these tasks that is being run here is being run on an individual container that's just spun up for the life of that task. What that allows me to do is build a lot of custom tasks with a lot of custom containers with the tools in them needed to run each step. So for example, here I've got a clone step here, and this is just a BusyBox image that has got access to Shell and to Git that is capable of cloning the repo to the workspace that Tecton is using. But I've also got an Ansible runner task here. And what this is doing is you may recognize this as the format of an Ansible playbook command, as I showed locally. And what's happening here is I'm actually running those Ansible playbooks from Tecton, from automation. And what this one is currently doing is compiling the code for CBSA, and it's compiling it on the managed node, so on the Z mainframe. Now, you might have noticed that we're already getting a bit of visual feedback on the GitHub repo. What's actually happening here is I'm providing steps for my Tecton pipeline to interface with the GitHub checks API. This allows the pipeline to create GitHub checks on the PR. And what I can do is provide feedback on what the pipeline's currently doing directly to the text, which appears in the GitHub checks. I wanted to really represent two tests here. So we have a regression test that checks if the code passes all of the Glasser tests. But also we really have another check here, which is, does the code actually build? Does the code compile okay? So this check here is just verifying that the Ansible playbooks can compile and install the application. Oh dear, we've got a failure in our CICS provisioning. Ooh. So yes, there we go. There were some funny things happening on that mainframe this morning. So it looks like the submission of the job failed. Right, so this is our opportunity to have, I think, what Mark Lawrence referred to in the DevSecOps presentation as a Blue Peter moment. So I think what I will do is I will jump over to our pull request that worked for Share Orlando 2024. But before I do that, I might just have a quick look in changes for GSC. It looks like my finally block hasn't quite caught that. So what we should see here is that this fails to complete the PR builds check, and then you can't merge this change because something went wrong in the provisioning. Let's have a look at what this looks like for a one that worked. So you can see here I've used this for development, so I've been opening and closing this PR quite a lot. But at the end of it, we've successfully provisioned and tested an instance of CBSA running the code that's in this branch. And as a result, we've got positive feedback that the checks have all passed, and we're, as a result, allowed to merge this into the repo. So that's really setting that kind of hard quality gate requirement on the code going into the repo there. So if something goes wrong in your Glasser test, you actually have a few options to go and figure out what happened. So what I'm going to do is I'm going to see if my checks for this have got a run ID. Looks like it hasn't got a run ID for my run. So I'll just demonstrate what you can do locally. So if I go over to this window, I should be able to do glassrctl runs download. Let's do U92 as a random number, I think, to give me a name. What you can see here is I have just run a Glasser command, which has allowed me to download the run log from a run in the Glasser ecosystem. So because I couldn't get the run name, it wasn't exactly that run that we wanted from the pipeline, but it's an example of a run that you can, the way that you can pull logging information out of the Glasser ecosystem. Okay, so I think that gives us a an overview of the CI/CD pipeline there, the automation that we've set up, how it looks when it goes wrong, and how it should look when it goes right. I do have a recorded video, but I won't subject you to that now that I've shown you a run that works. So just to finish up, I want to just provide some ideas for next steps that we're going to do with this project. So a few of the ways in which this pipeline is going to be extended, and a few ways in which we're going to implement this in the CIP team, and some sort of thoughts that you could maybe take away for your own pipeline infrastructure. So what I've demonstrated there is the way that deployment and tests can be linked together into an automated pipeline. But really, what that pipeline is doing is quite open and can be configured by providing it initial configuration at the start of the run. So what the shape of the environment is that gets deployed and what the tests are that get run against it really are quite open. And by providing specific configuration, you can actually create the concept of development levels. So in CIP, we have got development levels, which are dev, integration, pre-production, and production. And by providing configuration that changes the way the CICS application looks and the specific tests run against it, we actually can represent that in our pipeline. And a way in which I'm currently investigating implementing this is by having different branches representing the levels, and the event trigger that starts the pipeline will select the development level based on the movement of the code. So again, sort of centering this back on where is the code moving to. There's also a lot of options for optimization here. Tecton is parallelizable. In fact, it's parallel by default. That's how kind of core parallelization is to the Tecton model. And Ansible has also got quite a few options for parallelizing the individual task runs. There's a lot of steps in this demo that could actually be refactored so that they don't overlap in the resources that they're using. So greatly accelerating the speed at which we can perform this build. And I'm also, I've actually implemented Delta build options for other projects that I'm doing at the moment. So recompiling only code that has changed since the last build. Lastly, what you've seen there is utilizing the ZOS CICS operator collection to provision a single CICS region onto which we're installing the application. But that doesn't really represent the full picture of what we can do for deploying environments for the Bank of Hursley Park application. So a natural extension here would be to provision a whole CICSplex and set up all of the connections between the CICS regions and then roll out an installation of CBSA onto all of those. And that would better provide sort of an emulation of a customer environment. These are all points that I'm looking at the moment, and if these are of interest to you, come talk to us because I will be sharing my experience on how we have gone about all of these processes and how we've integrated that into the existing pipeline. So, a last point, CBSA again is open source and it's available for download from this repo. The repo currently contains all of the code for CBSA and installation instructions to allow you to manually install it on a ZOS host. I'm working on getting the automation here out into that repo as well, because it would be really nice just to have Ansible playbooks that set this up for you. So that's coming soon. But yes, feel free to go and have a look at that, see how the application relates to your own environments. But I think that covers everything that I wanted to go through for this talk. So yeah, just the key points here. We've got a demo application and we're working on creating a CI/CD pipeline to deploy it as an example of how this is possible with current technology on ZOS. So that brings me to the end of the content. We have got a session feedback form here, so I'd be really interested to hear any feedback for me and James on the presentation. And yeah, the CIP project really, its most important feature is in maintaining alignment with customers of IBM. So we're very, very open and approachable for any kind of feedback or any customer conversations.
Tom, you did get a question in the chat.
Cool.
Them being that they asked for the link, which you put on the screen, so I've transcripted that. One of the questions, which was a little bit earlier, was you mentioned that you run CBSA app with the workload. Can you share code for workload generation? Customers would like to see how, let's say, 1,000 transactions per second impacts a CICS region where CBSA application is run.
Right. So, yes, and there's another question on sharing Galassa testing code so customers can test their CICS environment setup. Yeah. So, what we currently have for Bank of Pursley Park application is that there are two aspects of this, I think. There's generation of customer data, and that's done initially outside of our operations workloads. So a lot of that customer data that you saw in CBSA there, that's all generated first by a COBOL program that creates a lot of customers. But then after that, we've got TP&S workloads. But at the moment, those currently only apply to the Bank of Pursley Park application. So they're not currently open source. But yeah, I think there's a really interesting point in there that it would be nice to have, here's CBSA, and also here's how to install it and then test it under load. So test it with a sort of high performance workload. I think currently Galassa doesn't particularly support that kind of high workload testing like TP&S. So we would need to look at a way of porting what we've got for the Bank of Pursley Park application over to CBSA. But it's a really interesting idea because, yeah, it would be nice to have some way of showing not just here's the application, but then here's how you could run a workload test on a CICS application. For the Galassa testing code, we will look at open sourcing that as well because it is scoped to CBSA. That would be a really good thing to do to just demonstrate how, the process of creating Galassa tests for an application, the process of creating a Galassa application manager as an extension to an existing manager would be quite good. So yeah, they're both really good questions. So just to play back, the automation for workload testing applies to our larger application currently, but that's a really good point. We should look at porting it to CBSA and open sourcing it. And for the Galassa testing, we will look at getting that into the open source repo as well. Great feedback. Thank you.
Cool. Thank you very much, James and Tom. That was really good. Like Tom said, if you can fill in the session feedback, that'd be absolutely amazing. And that is everything. Thank you guys for that. It's really, really interesting. And I'm sure people greatly benefit from the link you put in. They can have a look at CBSA a bit more there. And I think that's pretty much it. Thank you so much, guys.
Great. Thank you, everyone. Cheers,
Right,
James and Lewis.
Thank you.
See you.